Number Theoretic Functions Part 7. Summing capital F over a range of values. Welcome to the seventh and final part in the series on number theoretic functions. Here we prove a second formula connecting capital F and little f whenever capital F of n equals the sum of little f of d over the divisors of n. This formula concerns the summation of capital F over a range of values from a lower bound of 1 to an upper bound of capital N. In particular, the formula is the sum as n goes from 1 to capital N of capital F of n equals the sum as k goes from 1 to capital N of the box value of capital N upon k multiplied by little f of k. Again, to prove this, we resort to the definition of capital F as we have done in the past. This yields the sum as n goes from 1 to capital N of capital F of n equals the sum as n goes from 1 to capital N of the sum as d divides n of little f of d. The idea we will make use of is to group terms with equal values of little f of d together, similar to what we did in proving the Mobius inversion formula. This is done in the following way. First, we consider a specific value of d equals k and note that if k divides n, little f of k appears only once in the sum as d divides n of little f of d for a particular value of n, but multiple times in the double sum. In fact, little f of k appears whenever n is a multiple of k. This is the meaning of k divides n. Thus, there are precisely box capital N upon k occurrences of the term little f of k in the double sum, as there are box capital N upon k multiples of k in the range of n greater than or equal to 1 and less than or equal to capital N. The next point to discern is what the range of valid k values is. This is simple in light of the fact that for any n, k equals n is itself a divisor of n. Hence the term little f of n appears for each value of n greater than or equal to 1 and lesser than or equal to capital N, and so k2 has the same range. Thus a summation can be recast as the sum as n goes from 1 to capital N of the sum as d divides n of little f of d, which equals the sum as k goes from 1 to capital N of the box value of capital N upon k multiplied by little f of k, which is exactly the relation between capital F and little f we sought to prove. Now, a series of number theoretic functions draws to a close. I hope this series gives you some valuable insights that you can apply to problem solving, and that it has also built a rock solid understanding of the theory behind number theoretic functions. With that being said, I now take leave. I hope to see you in a future video. Thank you for watching. Again, as a postscript, I mentioned that the credit for the theory and the proofs goes to David M. Burton, who is the author of the book Elementary Number Theory. Credit is also given to McGraw-Hill Education India Private Limited, who have published the Indian edition.